a pipe flange or nozzle. This industry is one that hasn't really gone towards any type of closed molding because some of the corrosion specs, as they're written, are quite old and require, believe it or not, hand lamination, open mold. So we are challenging that industry to look at a more consistent method such as light RTM, and that's what we're going to demonstrate today, me and my colleagues here. But first, just a little bit about the marketplace. Corrosion growth, there's growth in the corrosion sector. Year after year, it's one that's growing along with oil and gas is back running again. That falls into that sector. So we've got a continuous growth market in pipes and tanks and other things that support the chemical industry, the chemical sector. These folks tend to like to use composites versus metals and metallics because of the corrosive nature of many of the products that they use. When do I know when I want to move towards a light RTM type of process?
Well, certainly for environmental issues and for employee exposure, that's a huge plus. Not to mention the labor savings and the quality that you're going to get. You can see from the parts that we made earlier, I mean, they're void-free basically compared to anything you could, your best laminator could do. And certainly it's going to increase your production. In this case, probably takes 20 minutes to load this. It's going to take a minute and a half to inject it. You know, so you've really got 25, 30 minutes of labor in building this entire piece. This is something you could certainly train somebody to do in a couple hours to be able to repeat it. It's a repeatable process, especially with the kits that we have. They're being pre-cut, so we drop them in.
Got to create a cavity, right?
Absolutely.
So this is a two-sided mold system. And let's talk a little bit about the upper mold before we put it on. They can't see it anymore. So this is a...
Just stand it up, maybe.
Maybe go to the camera for this.
So what we'll do, this is going to be our vent here where we're going to witness at the last point. We're going to inject our resin here in this port. It goes around our resin runner. There's a trail to go around there. It's going to inject the resin, and then it will flow simultaneously all to the bottom. Okay.
Okay, you saw that wasn't very heavy. It's called light RTM for a reason. And there is some flex to the mold. This gives you plenty good dimensional control, certainly for industrial specifications and even some transportation specs as well. If you needed tighter tolerances on the thickness, you might have to go to full RTM instead of light RTM, which is more supported, steel supported and heavier. Something even this big, we need an actuator to move it up and down.
Correct.
So we're going to get the vacuum on this mold here started, and then we're going to talk about the material kit that we have inside here. All right, Andrew, we're ready to inject. We got the mold closed. We got a good vacuum integrity, just as Jug referred to. We're ready to pull the trigger. What's going to happen over here on the equipment?
All right, so basically all I have to do is hit stop on this button. I'm going to hit inject. You're going to see this piston open up. When that opens up, it's allowing the material then to go into the mold. We're going to inject the mold. We'll see it come out of our side tube. We're going to shut off the machine. When we shut off the machine, the piston's going to close down, lock the valve out, and we're going to flush, which is a predetermined amount of 200 cc's flushing through these lines into our waste bucket. Everything clean and simple. So if you guys are ready to inject.
I should say that you're catalyzing it with the United Initiators product over there in the catalyst, and we've chosen a kind of mid-range level of 1.5 for the kind of cool in here this morning. So let's go ahead and do it.
All right, so here you go. I'm going to hit inject. The piston opens up. Here comes your material. Now it's going into the mold.
It's currently going around the resin runner that goes around the peripheral of this part, and then it's going to feed down the sides and come out to the vent at the bottom.
If you look at something like a caustic environment, it's really the resin that is protecting the glass. So the glass gives you all the mechanical properties, but the resin has to protect the glass from the caustic environment because that caustic environment will actually dissolve the glass. So in the corrosion barrier, it's a very resin-rich layer right at the surface of the composite itself. So in this case, in this corrosion-resistant flange, that resin layer is typically reinforced by veil material. So depending on the application, it could be a synthetic veil, commonly Nexus is used, or it could be a sea-glass veil. And that gives you something like about an 80 to 90% resin-rich surface.
The BIC A560 could be added either by the resin manufacturer or by the end user on site anytime before usage.
Okay.
It's a pretty thin liquid, and it'll just mix right into the vinyl ester, and a couple minutes of mixing, and you're ready to go.
So in my corrosion barrier that we're creating is it'll cause less voids to be in there, right?
That's right.
What's our layup look like for this?
So we start out with what we talked about earlier, the corrosion barrier. It's a very thin, lightweight sea glass veil. Provides a very high resin content surface for corrosion.
What it is this is our universal fitting. It goes on everywhere you're going to communicate through the tool. It's important to get the flange correct. You want a minimum of 8 inches from the resin runner out. And we've been doing a hands-on 4-day school all over the U.S. We just did one in Florida not too long ago.